Hello everybody again and welcome back. This is an example. I assigned 4 homework problems. This is what we're going to be doing. These 4 problems on page 480, number 9, 17, 20, 24. Hopefully we get all 4 done in this video. But what we're doing is classifying series, series as absolute convergent, conditional convergent, or divergent. And in order to do that, we'll just set this up real quick. Just let this be a alternating series. Then we're going to denote the positive series like this. Then is the the positive series, where all these a sub n's are positive, so this is a positive series. I guess I'll put that in quotes. And the way you do that, absolute convergence, means both of them converge. And all you have to do is show that one converges, and certainly the alternating one does. Then there's conditional convergence. And that is when this one converges, the alternating one converges, and the positive one diverges. And of course, I'm not even going to bother. But if they're both divergent, and then they're divergent. So yeah, divergent. I'm not sure. Certainly none of these homework problems are divergent. So let's start with number 9. Sum of n over 2n. N over 2 to the n. I'm just going to use the ratio test here. And I'm just going to do it on the positive one, because if the positive one converges, the whole thing does. So I'm going to look at n plus 1 over 2 to the n plus 1 over n over 2 to the n, and then we're going to flip and multiply. Like that. These go, it's n plus 1 over 2n. Something like that. And now we want to take the limit of this as n goes to infinity. As n goes to infinity, which is a half. A half is less than 1, so this converges absolutely. So by the ratio test, this converges absolutely. Remember, if you get the positive one to converge, then certainly the alternating one converges. Okay, let's try 17. Whoa, eraser. 17. 17. I'll write down 1 over n log n. Okay, that's what 17 looks like. And please note the boundary, it starts at 2. You can't put a 1 in there because you'd be divided by 0. So, I'm just curious. So, let's see. Here's the way I did this. I'm going to compare this. Let's see. What am I doing? Note. N log n, oh yes, this one, is less than n plus 1, ln n plus 1. So that 1 over ln n plus 1 is greater than 1 over n ln. Right, that's the lesser of the ones. So, therefore, in the alternating series, a sub n is greater than a sub n plus 1. That's one thing. And then two, the limit of 1 over n ln n, as n goes to infinity, is 0, which means that this series converges. Negative 1 converges. Now we got to test the regular series. We're not going to make all 4 of these, are we? So now let's test for convergence. Let's test that for convergence. I'm going to use the integral test because I'm looking at this as a function. Let f of x equal 1 over x ln x. Then clearly it meets the 3 requirements. Is continuous, positive, and non-increasing. And that's why I'm using the integral test, because it meets the function meets those 3 requirements. So now I'm doing from 2 of this function. You may recognize that. You u substitution, let u equals ln of x. Let u equals ln of x, and du then is 1 over x dx. Meaning that ln of x from 2 to infinity, which is infinite. This series diverges, so the problem itself is conditional. Conditionally convergent. One more. Let's try 20. 17. Let's try 20, and I don't know if we're going to get to 24. We'll just do the best we can here. Number 20. I may have to stop during this and start over because we're at the 8-minute mark, nearly. Okay. 20. Where are my 20? No, that's 24. Well, never mind, 20. I don't think I have done. You're kidding me. Well, let's do 24. Where the heck is 20? Oh, here it is. Sorry about that. Minus 1. And it equals 1, I guess, to infinity. There's number 20. Number 20. Please note n squared minus 1 is less than square root of n squared minus 1 plus 1 minus 1. So I just added 1 to that n. So therefore, 1 over the square root n squared minus 1 is greater than. So therefore, a sub n is greater than a sub n plus 1. So it's decreasing. And then, so furthermore, let's find the limit of this. The limit, as n goes to infinity, 1 over square root of n squared minus 1. This is getting big, is 0. That series, the alternating series, converges. Let me just read to you. This one is going to be conditionally convergent. Now, I'm going to get back and do another video doing the second part of this to show that the regular series is divergent. So that's going to be conditionally convergent. Number 24, just read the answer, is absolutely convergent. So I'm going to get back to another video to finish number 20 and do number 24 at 10 minutes. Let's start.